Now, what's the time? Oh, I need to hurry up a bit. So I've already mentioned the FAT plus partition. So currently the FAT plus partition contains 5 nodes with 1.5 terabytes and 1 node with 2 terabytes of memory. In general, please don't just start using the FAT plus partitions, because we've had multiple people who think they need a huge amount of memories but actually don't, and just waste resources there. So start in medium. Then if the memory isn't enough, and usually you get specific error messages that I come to later if memory isn't enough, then you use the FAT queue. And if that is still not enough, then use the FAT plus queue. If you really don't have enough memory, you can to find that out. You can use sacct. I come to that soon, and profit-hpc to find out if it's really the case. This will also be explained soon. Azad, I hope you can explain that again. Otherwise, I'm not prepared to do that, but not now. If you are not sure what the problem actually is, then feel free to ask us. I'm happy to help you before you waste some memory on the FAT plus queue. So always try that. If you use the FAT plus partition, you need to give the mem or the mem per CPU option. Oh, there should be a space here. And if you waste resources, well, we might not be happy. Okay. No, Azad, I'm not really prepared for that. I only did it last time because you weren't there. So if you can prepare it quickly on the side until I get there, that would be good. If not, it's not that big a deal. Okay. That was just to Azad, not to you guys. Now I have some more examples. So I've mentioned earlier that there is the idea of hybrid jobs. Hybrid jobs combine MPI and shared memory. So essentially, for MPI, usually if you want to have 20 cores or 100 cores, you start 100 tasks or the program 100 times. What you can do with the hybrid jobs, you can say like, okay, I just start my program 20 times, and each program uses 4 cores. So in the end, does it make sense? No, 5 cores. So in the end, you still use 100 cores, but differently distributed. And you can use the task per node, for example, and CPUs per task perfectly to use that. So essentially, usually if you use OpenMP, you have a variable called OMP num threads, and you can set that to a Slurm internal variable. To be honest, if you need it, just look up these slides, because most of you, as usual, will not need it. But yeah. Which far more of you will need is longer or shorter jobs than the usual default runtimes. So essentially, if you don't do anything, the default maximum runtime you can give with -t or --walltime is 2 days. And if you want to have longer jobs, which is usually the case, or often the case, you need to specify a quality of service, a QoS. So there are 2 extra QoS. First, short, which is basically shorter jobs, maximum 2 hours here. So you might wonder, why would I do that? It has a higher priority, so they run faster, quicker. Like the job itself doesn't run faster, but they don't wait as long in queue. And there's long, which has a maximum runtime of 5 days. Also, there's only limited job slots available, so we have a maximum number of concurrently running long jobs. Because the problem with longer jobs is it's not like we want to stop you and just want to do it for fun and torture you with short jobs. The problem is that nodes just happen to fail, and sometimes. So first of all, nodes sometimes fail for reasons. Then there might be file system issues that leads to drop crashes, or we might have to reboot the whole cluster step by step. Usually you don't even notice that, but sometimes there's a bug in the, for example, something in the kernel that that leads to that would allow hackers to get in. So we need to reboot the whole cluster. It doesn't matter if it's just short jobs running, because we can just say, okay, close the node, reboot it once all the jobs are done. But if there's like a 15-day job running, we have to wait 15 days, and we can't do that if it's a security vulnerability. So we limit it. And in the case that we make these exceptions, that we have longer runtimes, we might actually kill your jobs anyway if it's, for example, security vulnerability. That is the reason we need to reboot something. So in generally, we do it for a good reason. We limit it to a maximum runtime of 5 days. But I know sometimes jobs need to run longer. Not everything. So the first idea would be parallelize it better. That's easy to say, but hard to do sometimes. I know some softwares and some problems are more easily parallelizable than others. But this is always the nicest first step. Secondly, can you maybe break it down into whole smaller steps? Maybe you don't need to run your whole pipeline in a single job. Maybe you can break it down into smaller jobs and run them one after the other. There's even this thing called job dependencies that is quite nice for that I'll come to later. Also, check if your software supports checkpoints. Checkpoints is a way of basically writing the current state to a disk and then start from there again, which is quite nice. So you can just say after 2 days, okay, write a checkpoint and end the program, and then start the job again and start from that checkpoint again. Also, we've had the issues. You might wonder, why is this passive-aggressive check again here? We've had issues with people saying, no, it doesn't support it, and once you Google it a bit, yeah, it does support it. So, please be thorough when you look that up. And if it all doesn't help, there are ways we can do exceptions for your jobs, and especially if it's like once or twice, then sure, we just increase the limit a bit. That's not a big problem. Just try the other steps first. Right, and now something that I should move a bit up a bit more actually, but no, it's obviously now here. How do you get information about the current system status? So there is a bunch of Slurm commands that you can use to get information about your jobs and the whole system itself. So they're nice here on the slides, but I'd rather have them interactively. So the first one is sinfo. All the Slurm commands start with S for Slurm. And as you can see, you get lots of information. You won't get as much information. You only see fat plus, medium, GPU, and interactive. So it's not as complicated for you. But nevertheless, if even that is too much information, you can do, for example, -s, which means summary. Then you have like fat plus. There are nodes. This basically says, okay, these are the nodes. There are 6 nodes allocated, 0 nodes idle, 0 nodes in some other state, O for other, and so in total 6 nodes. Medium, the star denotes that it's the asterisk denotes that it's the default partition. So we have almost 150 allocated, some idling nodes, 1 in state other. I don't know what's going on there. And so 163 in total, and these are the names after that are there. And so on for everything. Oh, also the maximum time limit here. You can also show the info about a specific partition. So let's say we want to have information about fat plus. We can see all the nodes in fat plus with P for partition. Essentially the same is true for, so next thing is SQ. SQ, as you might guess from the name, displays all the jobs in the queue, which is quite a lot. And not only that, when I'm at it, you can also see like how many nodes, how long it's running, which jobs with node it's running on, the partition, the name of the job, the user, and the job ID, and even far more than that. To make it a bit more usable for you, you could do this sq-me. This only shows your job. As you can see, I don't have a job running at the moment, so this is kind of unspectacular. So I'm going to go back to this one, but now I'm going to say, okay, sq, but only the jobs in medium. Still a lot, but it's a bit less. I mean, you can't tell from looking at that. What the hell? If I now pipe that into less, you can see. So the last column either displays the name of the job it's currently running on, and there seems to be some problem, but I'm gonna look into that some other time. And it can also see the reason why it's not running. So either it's the node it's running on, or if it's in pending stage, short for PD here is short for pending, it says why it's not running. So for example, this one says resources, which means it's on top of the queue. It's the next job to run on 25 nodes. That's quite a big one. And so it's just waiting for the resources to be freed. Priority means it's just currently waiting in queue and it's not on top of the queue, so it's waiting for it to wait long enough to be on top of to be the top priority. As soon as it is the top priority and would run next, it changes to resources. And then there are some other more esoteric things, like those are job array things, or what's that? Yeah, some other things. You won't see those that often. Dependency means it depends on another job. Most of your jobs will hang in priority. There's lots of more stuff you can display here. Look into the man page. It's all described here. Now, next one. Yeah, what I already showed you was you can do s-control show partition medium to get some information over that. So the total number of CPUs, total nodes, the maximum time, which nodes are in there, the default time. So lots of stuff that we configured. You can also do that for single nodes. Oh, but then you need to add node here. Now you have all the information. So about the node 001. It has currently 67 nodes allocated, CPUs allocated of the total 96. It has 380 gigabytes of RAM, but a significant amount, if I see it correctly. No, it's kind of hard to read this. Anyway, you can see how much it's used at the moment and how much is still free. You could also have show job and give some random job ID. Hello, let's take this one. And then you see a lot of like who sent the job, which state, what's the time limit, and everything. So keep in mind, everyone else can see that about your jobs as well. So if you have any very important data that you want to keep out of vision, don't keep that in mind. Yeah. More. Right, sacct. Sacct takes information about the from the accounting database, and this has, so you can basically with -j you can take a look at a specific job and you can see, okay, it ran on the partition. So the problem is the s-control thing about jobs fails like 2 minutes after the job is done, because then it's not known by Slurm itself anymore, but only by the Slurm database. So then you need to go to this to get information, and what's also interesting, you can see how, for example, how much memory did it consume, which is important for these memory jobs. In this case, max RSS means maximum resident set size. This is essentially the maximum memory on a single node. In this case, it failed immediately, but I sadly don't have an example for a job that is that actually needed some memory, so I can't really show you quite well. And it has to be a finished job. So I'm sorry I can't really, but this would be one way. Just put in your job ID here, and then you can get a value of how much memory you consumed. I'm not quite sure in what's the unit for that, but I'm sure that Slurm, the man page, knows. Doesn't say it. Maybe it will display it as. I think it has a suffix then. There is like a bunch of, because the command history question, I do have them on the slides, and most of it is. I will not give you a complete command history, although hopefully I will have the time to edit this video together and upload this, so you actually will have that by watching that. But the commands itself are with some information on the slides. So the whole partition thing for isinfo, for this me, the s control show partition no job, the sacct -j, and some options you can give. So I have a lot of that on there. Yeah, last but not least, which I will not show you anymore because it's kind of confusing, is sprio. No, that's nest to feel. Sprio shows priority information about pending jobs. And what is also important, if you start a job and then notice something is off and you need to cancel it, there's scancel. You can either say scancel and then the job ID, or scancel and then something like -p partition, so you cancel all your jobs in, for example, the medium partition. Or scancel -u and then your user ID, then you cancel all your jobs. You can't cancel jobs of other people. So don't worry about that. Okay, what else? We have GPUs. I mentioned them at the beginning. They are in the GPU partition, so you can't do that on medium partition, but you can request GPUs and specific types of GPUs. So the format is -g and then type :number. CPUs are more or less pretty much evenly distributed for every CPU. You don't have to ask for them, but you can also say, I want to have that many CPUs. That also works. You also have GPUs per task if you have multiple tasks. You have GPUs per node if you have multiple nodes. But if you have just a single, most of the, like 99% of our GPU jobs are single node with few GPUs. You can take a look. Wait, you can take a look at our current GPUs by using this thing. This shows you this amount of GPUs. So you have these nodes have 4 RTX 5000, which are quite powerful. These two nodes have 8 V100 with a double precision, very expensive GPUs, which you can use. And then we have a few more, bit of an older generation. If you want to just play around, you can even use these. They are quite old. So if you want to srun GPU G1, you don't have to give a type. You can just do this. And let's say pty bash. And now you're wondering, how can I actually tell if I have a GPU? We automatically set the CUDA visible devices, which is a normal environment variable that most programs use. And you can see it is set to 0, which is basically what it should be set. So you get CUDA device number 0. I am on hostname. Yeah, that seems nice. And I could now use module load CUDA. I think it's that way. And use NVIDIA SMI, for example, to see, okay, I'm on a node on a GGE 012. and have a GTX 980, just as an example. Okay, that's essentially, by the way, all I do for GPU. If you have more questions, ask them in the chat. Now a few words on debugging. So I still didn't fix that one. Essentially, you can take a look at your so if you feel like there's something wrong with your job, you can take a look at your output files while the job is running. So you can do, for example, tail-f path to your output file, and then it will print on the screen what is written to that file. So you can actually see your job happening while it is happening. What you can also do is SSH into a node where your job is currently running. So you can, if you have a job running on a node, you can SSH into it, and then use hjob, for example, to see, okay, how much processor, how many processors do I use? Do I use all of the RAM memory I need? Do I actually use all of the processors I've expect to use? And just have a look while the job is running. Another thing is we add quite a lot of information at the beginning and at the end of the job, and just take a look at it. Is it the right partition? Is it the expected node list? So this is the list of the node the job ran on. Does it make sense? Is that what I expected? Did it run as long as I expected it to run? Just take a closer look to what is provided to you. And very important, if you look into your output files, read the errors. So there's sometimes stuff like this going on, which says like, okay, I don't know what it means, but it says like OOM kill events, some process may have been killed by the out of memory handler, or something like task 3 out of memory. OOM, by the way, also stands for out of memory. So that might be a very good idea, might give you an idea, okay, maybe my job ran out of memory. What you can then do is run sacct, give the job ID, and add something like this, which puts as the output the job ID, the maximum memory it used, and the node on which that happened. In the end of your job's output, this is generate a profit-hpc text report. Run the following command: profit-hpc, and then your job ID. So this is the job ID that is the, well, yeah, obviously the job ID. Now, and by I mean Azad, prepared something for me which I can show you, which is not exactly that. This is basically a fake job ID. No, not quite that, but something. So because we don't have I don't have any job to show you at the moment. So this is a job he saved for me, and if I do that, I get a profit-hpc job report, which, that's even what it says on top. So in this case, you have some of the information again from before. Username, job ID, the partition, the nodes, how many CPUs, wall clock time, so wall time, the expected runtime, started, finished, the usual, like the meta information of the job. And then we come to the interesting part, CPU and memory usage. So we have, this job had 3 nodes, these 3. Each had 4 cores, and you can see, okay, 4 cores, 4 cores, 4 cores. It used this 100%, this 100%, this 100%, and HWM stands for high watermark, so the maximum. So this is the average, this is the maximum. And essentially, this, I mean, CPU-wise, this was quite good, so it was completely used all the time. And now if we go to the next column, it says memory used, the mean memory, and the high watermark. So you have 0.6 gigabytes, and 0.58, 0.56. In the end, combined 1.7. High watermark was a bit higher, but in general, not that much. And you can see the allocated memory, which you actually had, which you you could have used is 20 gigabytes per node, which is 63. So you basically used no memory at all. It might be good, so you didn't run out of memory. On the other hand, wasted memory. Now, if I slide down, scroll down, slide down, you can see the GPU usage. Only if you use GPU, you can see the GPU usage. So here are the nodes again, the 3 nodes, and each node had 2 GPUs. That's the bus ID, basically, how it's internally represented. GPU 2 and GPU 3. The mean usage is quite low. So at 1%, the high watermark at 4%, you basically didn't use any memory. So this is the memory high watermark. And this is the CPU that is used for the for the GPU. So in the end, you can see that this basically it allocated 2 GPUs per node, but it basically didn't use them at all. So yeah, I don't know. That means like, okay, yeah, that's again the CPU, the same you saw up here. So for this one got two of those 4, and yeah, and then you get to the next one. This is GPU. Now we come to I/O and network, and what you can see here is how much did the job read and write to the to the file system and to the network. So here you can see on this node we read 24 megabytes of data, we wrote 0, and we didn't do anything from scratch, from the scratch file system, but we did communicate via InfiniBand, which is our high-speed network interconnect, which, yeah. So you can have an overview about your complete I/O and network usage. And then we have some more description of our nodes. So basically how many sockets. This is the node description, not the description of the memory of the hardware you allocate. No, not hardware. Not the resources you allocated. So it says available memory is 125. You didn't have the 125 gigabytes available. You only had 20 per node. Just to have, just as a precaution. And then in the end, it gives you a few recommendations. So for example, all GPUs have low usage, which might be caused by misconfiguration of the application or job, or some GPUs have more than one process using them at the same time. So just some nice general hints that we can that are easily deductible from there. Yeah, and that's. I hope I didn't screw this up too much, Azad. And I will get back to the part, to the usual Slurm part. But this is a very good tool to get information about your job, how it ran, and if it went into if it got some problems that you need to debug.